Greetings, I'm Peter Denning, host and moderator of this series of lectures on harnessing artificial intelligence. This is the final lecture of our series. We've covered a lot of ground here. Our other experts have given you a lot of perspectives on different aspects of artificial intelligence, and we're ready to leave you to go out into the world and put it to use. And all I'm going to do here in this final lecture is summarize a few points that I want to leave with you as you go forward. So that's our agenda for this last lecture. So our objectives in this course have been, first of all, understanding the meaning and definitions, dimensions of artificial intelligence. So, for example, the machine learning hierarchy, the implementation of artificial intelligence in key domains, and also strategy and risks that arise in using artificial intelligence. Another thing our speakers have talked about is strengths and limitations. So they've shown you places where they've used this with great success, places that look promising, and also limitations that they have to deal with and take great caution to deal with them. There's always a concern to achieve reliability and responsible use of these technologies. And finally, not finally, but one of our lecturers, John Aquila, talked about the new face of battle, which is how these technologies are transforming the way those who engage in war actually do it. We've already seen some of what John Aquila forecast take place in some of the recent battles, for example, in Ukraine, between Ukraine and Russia. A whole new type of strategy has been evolved because everybody's using drones and nobody is immune to being seen by a drone. Drones are also a way of delivering explosives cheaply. So this is an example of new face of battle being generated by artificial intelligence. And the final thing that we've been trying to help you do as you go along in navigating in the world is seeing through the hype. There's an awful lot of hype around these technologies. So basically what I want to do in this final thing is look at a few focal points of hype and talk about why you need to be cautious with them. So the first one is the claim machines are intelligent or soon will be. Second, large language models will become smarter than humans and eventually go out of control. Third one is there are dramatic breakthroughs in all applications caused by using AI. Another one is programming is dead. Long live machine learning. Another one is big data is the most important aspect of artificial intelligence. In other words, we couldn't do artificial intelligence without big data. Another one is AI confers unbeatable geopolitical advantage. One of our lecturers pointed to a comment by Russian President Putin claiming that whoever masters AI will rule the world. Well, that's part of this one here. Last one is when you're looking at AI, whatever there's good and bad, the good far outweighs the bad. Let's talk about each of these for a few minutes. Let's start with the first claim on the list, that AI machines are intelligent. So now we have a way of asking the question of if intelligence exists in the machines, where does it exist? And we have a series of levels: rule-based, supervised learning, unsupervised learning, generative AI, human-machine interaction, aspirational machines. That's our hierarchy. So where in this hierarchy can intelligence be? Well, the first few levels there are really about automation, of machine learning being used for automation, and there's no real intelligence involved in that machine learning. So whatever intelligence exists wouldn't be in those levels. Then as we go on here, we get human-machine interaction. Well, here, this is human intelligence amplified by machines, so the intelligence that would be present at that level is coming from humans and being amplified by machines. Well, you might say, okay, then the intelligence is an aspirational machine, so we hope one day maybe we can build intelligent machines, but they're not here, and we really don't know whether they ever can be built. So if you look around trying to find out where would the intelligence be, even if you're not exactly sure what it is, you can't find it in anything we've done. Second claim is large language models, one of the newest technologies, will become smarter than humans and eventually get out of control. Well, whatever we call smarter in these technologies, it can really be better than us in many ways, but it's also very narrow. So it's focused on a very particular kind of task. It can do the particular kind of task better than us. But so you might say it outsmarts us on that task, but doesn't outsmart us in general. We also know that large language models are parrots that repeat back texts from the training set that are statistically highly correlated with the prompt. And that's what they do, and that's not intelligent. The gap from large language machines to general intelligence is enormous. There's nothing on the horizon of improvements of large language models that cross that gap. There's a long list of things humans do in language that large language models cannot do. So this one is a shaky claim. Here's one here. Dramatic breakthroughs in applications are due to artificial intelligence. And most of the progress we've seen actually comes not from the artificial intelligence itself, but from the computing power used with special chips to enable the use of the previously expensive algorithms and data analytics. So in other words, a lot of the algorithms, neural networks already existed, but weren't practical because we couldn't train them on large enough data sets in any reasonable amount of time. So now that we have more compute power, we can do that, and we're starting to get the advantages out of these machines. And so most of the advances we see is coming from the machine hardware being better than it ever was, without changing the nature of the algorithms and data analytics. And there's been a few other advances that are coming from algorithm improvements. So as we look through here, you can see many areas where such claims are being made: data science, management, vision, cybersecurity. But again, most of the progress that we've seen the last few years is coming from the improvement of supercomputing power. So here's some more things there. Okay. Another one, this is a favorite one. Programming is dead, long live machine learning. So no longer do programs have to write out rules and debug programs. You just show them examples and the machines will learn it. So all the students who hate programming courses and learning how to find bugs and remove bugs and getting frustrated because they can't find the bugs, all of that will disappear because machine learning will take over for programming. That is the claim. Well, it turns out if you take a look at the codes that are generated by current generations of large language machines, they're small. They're maybe 100 or 200 lines long, And most of the software that you encounter out in the world is much, much larger than that. So we don't know whether LLMs can scale up to the size of programs that we see in practice. The other thing about LLM programs is they usually come out, they get started up and they've got errors in them. They have bugs in them, and so it requires some human being to review them and remove the errors. Well, with small programs, that goes pretty fast, and they wind up with an error-free code faster if you let LLM generate a draft and then you fix it than if you try and generate the whole thing yourself from scratch. So implementing good artificial intelligence is engineering. And that engineering has 4 components. Designing and programming algorithms. Yes, indeed, even large language models have a lot of algorithms in them. For example, the training process is all done by a standard algorithm. It's not done by machine learning. And when you have reinforcement learning with 2 machines playing against each other, the algorithms, we use normal algorithms to instruct those machines how to play with each other. So we haven't gotten away from good engineering and from algorithms. We can teach some things from numerous examples. That's what machine learning is all about. We use reinforcement simulations to help improve the machines. But we also must complement with rigorous testing, because we want to put these machines out into the field of applications, and we want to know that when they're being used by people, they're going to be safe and reliable. So we need to do a lot of rigorous testing before we can deploy a lot of these things. So many complex safety-critical software systems, such as operating systems, simulators, and data management systems, require rigorous rule-based designs. So programming is not dead. Maybe writing small, simple programs will be dead because people don't have to do it. But maybe you can get LLMs to write small, simple programs, but they're not going to be able to write large safety-critical programs. Another claim is big data is the most important aspect. So this claim tries to claim that all the progress in AI has been because we now have big data. So we have ways of collecting the data. Well, so there's a claim that there's a synergy between the big data and the neural networks. Yes, that's true. We can't train up the large neural networks without big data. And as we said, these things require huge training sets. So GPT-4 has 300 billion words of text in it, 1 trillion parameters. It was very expensive to train, and a lot of the data that went in to train it was of dubious quality, and some people ascribe that to the lack of really reliable good data. They ascribe to the hallucinations. It's also, to train the machine is energy intensive, so extremely expensive. It can't. So they look for, we'll train it once and then try and adapt it rather than keep on retraining it. So big data is not the driving factor. It's more like a limiting factor. And a lot of, as I said, a lot of artificial intelligence is programming. For example, the training process is programmed using standard classical programming techniques. So we couldn't have that AI without that programming. So big data needed for machine learning, but not for all artificial intelligence. Another claim is AI confers unbeatable geopolitical advantages. So that reminds us of the Putin comment. So we certainly get speed from AI, from the computing in AI. There's low cost of entry to it, so anybody can try and use AI. but it's also easy to misuse it. A lot of people have been talking about regulating it, but nobody's come to any agreement, so this seems to be hard to regulate, or maybe more precisely, hard to get people to agree on what and how to regulate it. These technologies are subject to adversarial attacks. In fact, that's a major research area, is trying to figure out how the enemy might attack your artificial intelligence and disable it, or how you might attack the enemy's artificial intelligence and disable it. And of course, everybody's trying to do the same thing. So this really limits a lot of the advantages. Okay. Another one claim is AI offers more good than evil. So as we've seen from what our speakers have told us and what examples they've shown us, is that we get good things from artificial intelligence, but some bad things can happen. And we don't need to go to a Hollywood scenario like Skynet to find bad things that happen. They happen anyway. The good can be really good and the bad can be really bad. So like big swings here. The AI, an example, I have an example of questions that are coming out of this thing here. The AI is being used to power ad targeting ads for social media for kids, and a lot of parents and others are worried about social media getting poisoned for kids because of ad targeting, and AI is driving that. Another problem is that troubling people is AI will claim certain things are true, especially the generative AI, and we're unable to verify it. Turns out a lot of stuff that comes out of there can be proved to be not true, but it's not easy always to find the facts to confirm or deny what the AI says. Another concern is whether adversarial attacks would render AI useless in war. Nobody knows the answer to that. We do know that in some of the recent wars, like the Ukraine-Russian war, everybody's using AI, and so far maybe they've got a stalemate in the war at the time we recorded this, but we don't know whether anybody got an advantage out of it. Then there's this question about singularity and extinction of humankind, which is kind of like a more amusing question. Nobody has a good answer to it, but doesn't affect the AI that we actually build, which is based on machine learning. There's a thing called a doomsday scenario called slaughter bots, which are little robots that can go out and assassinate people without being detected. So wondering whether that kind of scenario can arise. You don't like your political opponents, you get them knocked off by a slaughter bot. And finally, on my list, I have artificial stupidity, which means somehow or other we program in our own stupidity into the system, maybe without realizing it, and then believe that it's true. So these are examples of things that look like they can go bad. Nobody has good answers, and certainly aren't supportive of the claim that AI offers more good than evil. As we depart this lecture series, number of dilemmas, we can come up with a whole bunch of them all over the place. What are the geopolitical consequences of artificial intelligence? What about arms control and deterrence? Does artificial intelligence support that or not? How do we deal with fragility and unintelligibility or intelligibility? How do we deal with hallucinations and fabrications, deep fakes? What do we do with adversarial and untrustworthy or trustworthy AI? How do we tell? What about bias in the data, leading bias in behavior? How do we get reliable data? It seems to cost a lot. How do we make sure our data is reliable? What about intellectual property? Is that being violated by data gathering? Is intellectual property law going to interfere with the progress of machine learning? How do we keep humans in the loop? Do we want to? Also, there's civilian resistance to military use of AI, and a lot of people saying we'd like to have an AI-savvy workforce, but haven't gotten there yet. So we human operators need to find resolutions for these kind of dilemmas. And whatever the resolutions are, the machine can support them, but the machines can't find them. It's still a human problem to figure these things out. Well, where do we go from here? This is my final charge to you, if you want to put it that way. As you leave this series of lectures and go out and do your thing in the world, consider this. It's easy to become fascinated with the AI technology in and of itself. It's fascinating technology. It's ingenious, clever, and cool. But fascination with technology creates distance. A distance where others are pixels on a display. A distance that puts war on our screens as a video game, isolating us from its horrors and destruction. A distance that undermines our capacity for respect and increases our fear, anxiety, distrust, and resentment. As you move forward from this course, be vigilant. Look for AI that helps you do your job better. Do not get lost in AI technology fascination. Do not lose sight of AI's weaknesses and limitations. Do not let AI screen isolate you from understanding and respecting others. I thank you for joining us in this series. Thank you very much.